From the run mode, we go to the stop mode. And we can do that by one of two different ways. We can either click on the stop mode button with our mouse, or we can type stop directly from the computer keyboard. Now, when you enter the stop mode, you'll notice that the screen looks essentially the same, except there's a big red banner coming up the Record Play Studios, and it says that the organ is stopped and record and play are inactive. Now, you can also notice up here that the scanner shows no activity, and there's no scanning delay or anything else. Our real-time clock is up, and other than that, the screen is the same. And down at the bottom, it will tell you that all studio operations have been killed. Now, the stop mode is useful for several different things, and the most advantageous use of the stop screen is to find stops and check and test stops, or any keyboard or any console input to the system at all, not just stops, but keys, pistons, pedals, effects buttons, etc. And to do that, we call on what's called the console scan mode. And to enter the console scan, you type the word console and press the enter key. And then you'll be shown a blank display. And this means that it's waiting for you, and then you'll see down at the bottom screen it says it is scanning, and now it's waiting for you to turn something on in the console. So if we were to turn on a stop, it would display the information about that stop. First, over on the left, it shows its input wiring address, AAI1. It shows the programming element type. This is a STP, or a stop. It shows the number which is assigned to the element. In this case, it's stop number 1. And to the right, it shows a name that has been assigned to that particular stop. In this case, the 8-foot great violin. Now, if we were to turn on a key, then it again displays its wiring address, AAA1, its keyboard number 1, and the name is key C1 of the great keyboard. So it will identify things to you, and if we go over and activate a piston, then that shows its wiring address, AAM1, and its designation is a PST, or a piston, and its piston element number 1, and its name is piston number 1. Now, basically anything that you turn on will identify itself, so you can use this to test things. You can go through and turn on all of the stops on the console one at a time and have an assistant who can watch the screen and verify, okay, that stop is on, so on and so forth. And then you can go through the keys and do the same thing and check for wiring order. For example, if you go key 1, key 2, key 3, key 4, key 5, key 6. So you can go all the way through that, and then you can very easily verify your wiring input address order, A1, A2, A3, A4, A5, A6. They're all on keyboard number 1, and it's C1, C#1, D1, D#1, E1, F1, etc. And so you can easily spot a wiring error. So if you're going from C is the first one, and then you press the second key down, C#, and you get this D#1, then you've got a wiring error. So it will very easily show that the first wiring address was A1. The second one, which is supposed to be C#, is actually wired to input A4, which is D# of the keyboard. So you can use that to verify the order of things, the wiring of things, and the names of things. Now, you can also find broken wires or stops that don't work correctly. Now, the one thing that that the console scan will not show you is an input that was stuck on or was on prior to your entering the console scan mode. For example, if we escape out of here and we have, unknown to us, we have a stuck stop or a shorted stop input. We type console, and we come into here and we push stop number 1. Okay, that works. And then we go over and we turn on stop number 2. Well, that doesn't work. And then we go and we turn on stop number 3, and that works. So we can see that stop 1 and stop 3 worked, but stop 2 didn't. So the stop wiring address was I1 for number 1 and I3 for number 3. So we can kind of figure that, well, stop number 2 will probably be wired to I2. Well, how do we check that? So what we can do is escape out of here, press the escape key to clear the console scan, and then we go into a routine called test input, and its command is TI for test input followed by the enter key. Okay, so we see over here that I2 is on. So now if we come over and we turn stop 1 on, there it is, and turn stop 3 on, there it is. So I2 is stuck on. Okay, so now we can also see another very important thing here. Stop number 3 is flaky. It's got a bad contact address. It's kind of going on and off, off, on, off. Now the other two look pretty good. So if we turn stop 3 off, going back to our original problem, okay, now if we go over here and we turn the stop off, nothing happens. Now if we go over and we unplug the input address, let's see, let's turn 1 and 3 back on, and now we go over to the input port and we unplug the connector. Okay, they all go away, and now we plug it back in and they all come back, and we turn off 1, 2, still on, and 3. Okay, so we know that we've got a problem. Either there's a wire is shorted, or the contact in the stop is shorted, and or there's some other internal short inside the stop switch. So now if we go over to that stop and look at it, and if it's a magnetic reed, we want to carefully try and bend the reed either toward or away from the magnet. In most cases you want to bend it away from the magnet if it's on all the time. Or if this was a older type stop tab that had manual contacts, we'd want to try and look at the contacts and adjust them. So if we look at that contact very carefully, and although you can't see that because we don't have a camera on this, I'm going back and I'm playing with the stop, and if I bend the contact adjustment, oh, okay, there it went off. Okay, so now I bend that contact a little bit more, and now if I go back and turn on stop number 1, stop number 2, there it is, and stop number 3, there it is. Now I've got 3 solid contacts. Now 0, 0, 0 is the best contact you can have, and it means it's solid ground. Now if we go back here to stop number 3 and wiggle that a little bit, okay, now there it's going on and off. And so is stop 2. It's not quite adjusted well yet. Okay, so this will show us if we bring this up and we have our stops on, and we can see that we've got some bad contacts. And so you can do your adjustment. If you can swing the terminal around so you can see what you're doing while you're at the back of the console, then you can turn things on and you can verify, number 1, that the stops are working, and then if you got crummy contacts like these are presenting here, you can straighten them out until you get rock solid 3 zeros. Now you'll notice down here, down in the lower right on P8, we have a 087. Now what's that all about? Well, the system will also recognize potentiometers. So this happens to be the potentiometer that we've set up on this particular test setup, and it's on input board AA P8 is where the potentiometer is wired to. And you'll notice if I go down and I move the swell shoe, then I can change this value just by moving the pot. And it'll go from 0, 0, 0, which is completely off, all the way up to 255. And that gives us our value of expression. All the way up to 255. That's about as high as it's going to go, 254. And then it goes off. Now we're running a camcorder program in the background recording all this information that we're showing you here. So this system is being a little bit taxed with this camcorder running in the background. But anyway, you should see, and your system will probably be a lot more stable. But you will be able to see whenever you move the potentiometers that they will appear as values from 0 to 255 on your system. So that's what that's all about. And then once again, these are our stop inputs. And so that's how we basically find stuff. We can find stuck inputs that are on. The only thing we can't find is a broken wire. And that should be easily identifiable, because if you take, let me take a wire off of this potentiometer because it's only held on here with a little clip lead. And if you suspect that you have a bad input somewhere and you want to test the input to make sure that it is in fact good, you can take a test lead, clip it to common ground, and then go over and touch it on any input, like remove the plug that is wired. And if you suspect that K8, input board K, or input AAK8 is bad, unplug the plug and then touch a terminal that is wired to ground to it. Okay, and that'll show us that, yeah, the input board is good. But if we have a stop or piston or something else that's tied to that, then and it doesn't work, then that's essentially how you go back and verify that the input is actually good, but it's something between the input pin and the physical hardware itself that's bad. And we can go through and we can test our pistons. Those show up here, 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 here. So all our pistons are good. So we can go through all the inputs. Now you'll notice that this is set up here for input board AA. Now if we want to look at something that's on board AB or AC, you use the up arrow. Now the up arrow is down in the center quadrant of your keyboard, your computer keyboard, which is the up, down, left, and right arrow. You would press the up arrow and that would take you to input board AB, and then AC, AD, etc. Use the down arrow to go back to AC, AB, AA. Now let's go back to potentiometers once more, because I want to illustrate something else. If you have an input, you get a key or an input or something that shows a number like 22 or 23 when you activate it. Now that means that the contact for that key or that stop is acting essentially like a potentiometer that has a lot of corrosion or a lot of oxidation on it, and it's acting like a resistance, and it's not making a good solid ground. So if you have stops or keys, when you activate them and they show values like 22, and that means you got some key contact problems. Now this system has a threshold of where it determines what is on and what is off, and that threshold you'll find is about 35. So if you have a contact that is showing 35 or under, then it will probably work for a key or a stop. But if you get something that gets up around 39 or 40, or you get up to 79, that's not going to work. It may show that it's good here. It's showing that, yeah, it's making contact and it's showing a value of 78, but that is beyond the threshold of what the system determines as an on-off contact. So if you see this when you're going through your keys and your stops, especially if you have not renewed the contacts on the keyboards or the pedal boards, and they're really heavily oxidized, or it's not real silver contact, then you're going to find you're going to have some keying problems. and values that are showing in the 60s and 70s will not make good reliable contact, and you'll have all kinds of keying problems. So this will also show you those particular types of problems. Again, to get out of the test input scan, then you press the escape key and you're back to the stop mode. Now let's go through a couple of other diagnostics that are useful, and to do those you have to be in the run mode. So let's go back to run. And the first one that we want to test is called show signals. If we type the shortcut for show signals, SS, show signals, followed by the enter key, and that will bring up two windows. Now here it does things a lot like console scan. However, it'll show you what the input signal is, and it'll show you where it's sending it to in either the chamber or the console. Now, unlike console scan, it does not identify them by what their element number is or what the programming nomenclature for the individual item is. It will just show you the input address and show you whether or not the contact is on or off. So let's go up and turn on our stop number 1, and you'll see that it shows up as input AAI1, which is stop number 1, which we found in the console scan, and then it shows the number 255. Now, 255 means on in console input language. Anytime a console input is on, it's either going to be 0 or 255. 255 is on, 0 is off. And these numbers here, don't pay any attention to those. It's not worth explaining. And now if we turn a key on, then the same thing will happen. And we're going to turn on low C of the great keyboard again, and that shows up as AA A1, and 255 is its value, so it means it's on. But look over in the output signal side. Now you'll notice over here that it has turned on a chamber MIDI address. MA is MIDI, M being MIDI, A is channel 1, E5, and it shows that it's on. Okay, that's because we turned this stop on first, and then we turned on a key input. So when a stop and a key are on, they send an output to the chamber. So if I release that keynote, okay, then it shows that input AA A1 went to off, 0, and that chamber MAE5 also turned off. So we can use this to show signals coming into the console, or signals that are being turned on at the console, and where they're being sent out to in the chambers. Now what this is really useful for, let's clear this, escape, we'll clear the two windows. Show signals, let's bring that up again. That'll show us a clear screen. Is we can use this to test things like trems. Okay, sometimes you have many trems that are wired to a single output, or one stop switch turns on many different trems. Okay, depending on how you've got it wired. So if I turn on the trem tab for this particular setup, there's just one tab that turns on 5 different trems. If I turn that stop switch on, you'll notice over here that input AAJ4 turned on at 255, and it sent out to the chamber 1, 2, 3, 4, 5 different output addresses, and it turned them all on. Now if I turn that stop off, okay, first it shows me that the input AAJ4 has gone to 0 or off, and that chamber D1, D2, D3, D4, D5 now turned off. So if I want to, if I have a trem that I can't seem to get working, I go, geez, what's supposed to be turning it on and off? So if I go through all the trem tabs, then I can at least see what the computer is turning on and what it's turning off, and then I can go and verify these addresses through my wiring sheets, and I can find exactly what's going on. Now a more thorough test in the system would be called the trace. Now we can clear this by pressing the escape key twice. Now if I go into the trace mode, which is only available in the run mode, TRACE, it brings up a similar screen like the console scan, but this time anything I turn on will trace itself completely through the relay from start to finish. So we go through the same test again by turning on stop number 1. Okay, what it does is it shows that its AAI1 is on. Okay, and then it's a relay in signal block, and it's stop number 1, so it goes through a stop block, and that stop is assigned to the 8-foot great violin. It's also turning on function number 1, which is assigned as a function block type number 3, which is the 8-foot great violin. Okay, that's just turning on the stop. Now, when I turn on the key with the stop on, some more stuff happens. Okay, lots more stuff. And I release the key. So if I bring my scroll bar back up here, here's where I turned the key on, and here's where I turned here's where I turned the stop on. Here's where I turned the key on. Okay, 255 means that it's on. It was input address AAA1. It's an in signal block, it's a relay signal block. Okay, it's the great division coupler, and it's function number 1, the great violin, key 1, or rank number 1. And over here it tells us, okay, it output MIDI MAE5 on channel 1, which is MIDI note number 36 and velocity of 127. And then when I released the note, it went through and basically turned the key off. And if I scroll down here a little bit, you'll see that it went to MIDI output MAE5, turned that off, which was channel 1, note number 36, and then velocity of 0, which means it turned the note off. So this is very handy, especially in tracing MIDI inputs and outputs, because MIDI is a very difficult thing, as some of you know, to test because it's invisible. I mean, there's no way you can hook a meter to MIDI and see what's going on like you can a normal relay. You need something like a trace system here, and this will help you invaluably if you are trying to do MIDI program changes and it's not changing the program, or it's changing the wrong program. And so you can use the trace function to do that. Let me make a little pause here, and I'll go in and make a change in the definition file and show you exactly what I mean. Okay, now if we go into trace, and let's see, I think I have to back up here just a minute. Stop and run to compile my changes. Trace. Okay, and turn that off, turn it on. Okay, now you'll notice, start over again, TRACE, turn that off, and then go to, Alright, now, if I turn the stop on, okay, now it's done. I've added another feature to that stop. Not only is it turning on the 8-foot great violin, but it's also sending out a MIDI program change 33 on channel 1. Now this is the only type of system you're going to find in an organ relay that will tell you this kind of stuff. Because if you are expecting a MIDI program change 33 on channel 2, you would see that here that it's sending out the program change 33 on channel 1. So when you play that note here, then it's going to play the note on channel 1, note 36, velocity is 127, okay, and you're going to know that your program change is on channel 1. Now if I go back here, escape out of that, go back here, option 18, and I change this to MIDI channel 2, okay, stop, run, trace, and I turn that stop on again. See, now what it's done is it's sent the program change out on channel 2. So I can make instant changes and go in and verify them immediately as to what's going on in the system, and I can just basically run this trace, and it's going to show me everything that's happening inside the relay. So this is really a powerful diagnostic tool, especially if you're into MIDI problems and you can't figure out what the hell's going on. Then you can use the MIDI trace to help you find where your MIDI bottleneck is. And generally it's usually you're sending out the wrong program change on the wrong channel, or the channel is correct but you're sending out the wrong program change, or you're not sending out a proper program change. So that's just a couple of the uses and some of the system diagnostics that you'll find. So the next thing we'll start with is kind of a guided tour of the editor, and we'll go through some of those things that I very quickly did as far as that MIDI program change, and some of the other things you can do in the MIDI editor. So with that, we'll call this a wrap.